the last part, right, of 7. So it's actually 7D. Now you're looking at these two big molecules and you have to name them. No, just kidding. Not naming these guys, but what you are doing is you're pointing out all of the functional groups in this case. So we'll go through, we'll find all of those, discuss it. So you're pretty much looking for anything that isn't carbon and hydrogen. So right here, you have your OH functionality, which is an alcohol. You don't necessarily need to specify this one here. This is a halide or chloro group. This is different here. So you have just an oxygen that is bound to carbons on either side, just through single bonds. That is an ether. You just have to be able to recognize these. Okay? This one up here, C double bond O and an OH under carbon. That's a carboxylic acid. Another chloro, which you don't need to necessarily name. Other pieces in here, you have a benzene ring. There's an interesting feature of these two benzene rings. Over here is a much more complicated structure, but in this case here, you're just trying to pick out those functional groups. So don't get bothered by everything else that's in there. Focus on the functional groups. So up here, you see nitrogen bound to a methyl group, another carbon, and a hydrogen. So it's nitrogen bound to 3 things, but all of those are either carbon or hydrogen with nothing else on there, so just regular hydrocarbons. So this is an amine. Here's a nitrogen bound to 3 carbons, but in this case, this carbon up here also has a carbonyl on it. So this is a different type of functional group. Okay, don't split these guys up. This is an amide. And I've seen in the past people splitting this and saying amine and carbonyl or ketone. That's not the case. These guys go together because they're just one bond away like that. That is an amide functional group. Same with over here on the carboxylic acid. This is not an alcohol and a ketone. Okay, be careful. Here's an oxygen by itself, double bound to a carbon, and that carbon just has hydrocarbon on either side of that. So this is a ketone. See another one of them right here, because this carbon is just bound to hydrocarbons on either side. Here's another double bond. So it's a carbonyl functional group. Carbonyls show up everywhere though, like right, this is a carbonyl, carbonyl, carbonyl. Just C double bond O. So in this case, the carbon that is bound to this double bond O is bound to a hydrogen in addition to hydrocarbons, so a carbon with hydrogens on it. So this changes things. Instead of it being a ketone now, this group is an aldehyde. Okay, so the difference between the aldehyde and ketone, just this would have been a carbon on it instead. Now, some other interesting features of this that did not get brought up in this particular question, but I think you should be aware of, are chiral centers. So looking for that carbon atom that the mirror image of itself would not be superimposable. That's really hard to picture, but what you're looking for really is just a carbon atom that is bound to 4 different things. Okay? And a carbon on 4 different sides can be different carbons. So for example, let's pick out a carbon atom here. Let's look at this carbon atom right there. Okay? This carbon atom is bound to this, and it also has 2 hydrogens on there. Right? So that carbon atom is not bound to 4 different things because 2 of those things are hydrogens. That is not a chiral center. Let's find another one. Let's pick out this carbon right here. Okay, so this carbon is bound to this carbon up here, which is bound to this thing over here, bound to this thing over here, bound to this carbon and that carbon. And it also has a hydrogen. Remember, they all have 4 things bound to them, right? So the fact that these 3 are all carbons doesn't mean that they're all the same carbons. Think of what's after that carbon. So this carbon has all this other stuff. This carbon has this group on it. This carbon has this group on it. So all 3 of those carbons are completely different. And it's also a hydrogen. So this carbon right there would be a chiral center. You should go through and try and see if you can find more. Remember, it has to be a carbon that has 4 things bound to it. I'll point out another one in here. Okay, the there are more in that structure. That's it for this question.